Good afternoon, everybody, and a very warm welcome to our second presentation in our series on career highlights. My name is Jane Albiston. I'm the Professional Development and Advocacy Manager for Survey and Spatial New Zealand, and it's my pleasure to have you all here today as we listen in to hear from Michael Cutfield. So I'm sure everyone is aware of the Waterview Tunnel project and the fact that it was really the largest project that we've really had since the Harbour Bridge. It's fascinating, and Michael Cutfield was one of the key survey managers on that project. He's had a long career history. I'm sure many of you know Mike. He has been the engineering surveying stream lead on the Survey and Spatial New Zealand Council for many years, and has played a key role in our organisation and has had a long career in engineering, surveying and many other things. So when I asked him what his career highlight was, or what his career highlights were, he said without a doubt the Waterview Tunnel. So today we are very privileged to have Mike join us, and we're going to hear an inside view of his experiences and see some footage and presentation photos and things that you wouldn't have heard before. Just a bit of housekeeping. What we're going to do is we're going to hear from Mike, and as you hear from him, if you've got questions, please just type them in to the little box that you can see where you can put questions in, and then at the end of Mike's presentation we're going to have a look at the questions, and I will be putting them to Mike. So we're just going to hear from Mike now, and he can give you an update of where he is at now and what he's going to talk about today. So thank you and enjoy.
Thank you, Jane. That's a great introduction. And thank you, Jenny, also for organising this, and thanks for everyone who's tuning up live and who might be watching it at their own leisure. So yes, I've been asked to talk about my career highlight, and yeah, Waterview is, I'd have to say, would be the one. I've been on many infrastructure projects, so I spent 12 years in total with between Fletcher and Downer. Now I work for Survey Works, and I've been here for just over a year. But yeah, with my 12 years at Fletcher's, I've got to see some pretty big infrastructure projects. Starting from the start, it was the Tauranga Harbour Link in 2009. And then, so that was the second harbour crossing there. And then from there, I went to the Victoria Park Tunnel in Auckland. And then I went to the Christchurch infrastructure rebuild for a year in Christchurch, and that's when I came back to the Waterview Tunnel. After that, I moved on to the Pūhoita Warkworth project, which is still ongoing, hopefully about a year left on that one. And then I shifted across to Downer to be involved in the City Rail Link project, and I was there for a good couple of years setting that one up as well. So they're all quite big projects and all very interesting. I got quite addicted to them. Yeah, I really had to say that I'd been on the City Rail Link and to finish it all off, and now I'm here at Survey Works. So about me, so that's a bit about me. So what I'm presenting here today is the presentation that I did in 2014, because I was thinking about it. Geez, I hope there's not too many people here who remember this presentation that I did in the conference back then. But then I did the numbers, and it's 8 years ago. And so yeah, time flies. Oh, and sorry about the text. I have a different font on my version, so some of the text might be behind some of the images, so apologies for that problem there. But anyway, about me, yeah. So before I joined Fletcher's, you can see there I was in the UK, and that's where I really got into the engineering surveying. That project on the bottom right was really interesting, and we had to move a 1,200-ton bridge into place over a weekend occupation of the main line going into London Bridge. So that was very interesting, and that got me the taste for the big projects. Otherwise, yeah, before that I was in surveying around London, and you might recognise Wanaka there, as well as having a bit of play around the place with a bit of snowboarding. So the Waterview tunnel was the last piece of the puzzle to this Western Ring route. It used to roll off the tongue. Excuse me a second. I'll get my notes up to speed. And so yeah, it was $1.4 billion. That's the City Rail Link project now overshadows that. 4.4 billion was the last estimate for the City Rail Link. So it seems to be the factor that these projects go up in at about 4 times. So yeah, it was at the same time there was around the northern end of our project, there was the causeway going on and the St. Luke's widening as well. So all these projects working together to create this new alternative to the Harbour Bridge and State Highway 1. So it is 5 kilometres of 6-lane motorway, so 2 tunnels, 2.4 kilometres long, and a 14.4 metre diameter TBM. So that was the 10th largest in the world, the first largest in the Southern Hemisphere at the time. So since then, I'm not sure, it's the City Rail Link doesn't quite have those kind of stats, but 14.4 metres is quite massive. So 800,000 cubic metres of spoil came out of both those 2 tunnels, and there's 4 new interchange ramps at the northern end there, and those ramps in themselves were a project each. 55 columns, 48 crossheads, 7 abutments, 260 super T beams. So yeah, rather large. So first, I'm just gonna go over the spoil disposal site. So like I say, this is my slideshow from 8 years ago, but I've added this picture to the right. I hope you can make it out. But if you look at the top right of the picture on the left, you can see the Auckland Transport Rail Depot building there. If you look on the picture on the right, you can see it in the right corner there too. So the picture on the right is obviously the top down. Picture on the left is a little bit of a oblique view. So you can see where all the 800,000 cubic meters of spoil went. It was all dumped off at the bottom of the screen there, and you can see it getting pushed out. And what they did was they put it into what they called wind rows, all to dry out this spoil so it could then be compacted, and that land turned into productive land. So that was Old Wirri Quarry. So as you can see there on the left, it's all getting reclaimed with our spoil, and on the right, that is an aerial of today. So good to see that land become productive. Then there was the precast yard. This is where they made all the segments. Fortunately, my notes is working quite slowly. Let's see. And I didn't have the number of segments they made, but if you can do the maths, there was 10 segments per ring, and each ring was 2 meters long, and so there's in total about 5 kilometers of tunnel. So yeah, a lot of concrete segments, and like if you look at the road there, you can see a car down there at the bottom left. Kind of gives you a scale and what's being produced there is only the fraction of the amount of ring segments that was needed to line the 2 Waterview tunnels. So Jenny, if you wouldn't mind playing. So yeah, this was a video made at the time, 2014. Seeing John P there. Up. Talk over the top. This shows you how the tunnel was built. This was the boring machine. So you see there the concrete ring segments getting lifted into place, picked up by suction cups basically, with vacuum. That crane lifts them up and puts them into place. They get put in place on the shield, what they call the shield, at the end of the cutting face of the TBM. That shield moves along, and then those sprint segments go directly onto the ground, to the wall of the tunnel. And then grout is filled in behind, stabilising them. So you see the jacks pushing the segments into place. That's the spoil going along the conveyor belt, coming out back. That's the driver of the TBM, the big steering wheel, just a bunch of knobs. The air vent, fresh air in. So I hope you could hear me over that video. If not, you get the idea. Alice was the name of the tunnel boring machine. There was a competition amongst all the schools to come up with a good name, and some boy from one of the local schools, sort of Alice from Alice in Wonderland. And it's tradition to give the tunnel boring machines a girl's name. I think that's all based off of Santa Barbara, and yeah, if you look that up, you can find out all you need to know about that. But they often have the monument of Santa Barbara at the entrance for the tunnels for good luck and superstition or religious beliefs, depending on your point of view there. So the surface survey, I was manager of the surface survey team, and there was a north team and a south team and a monitoring team as part of that. And so also there was a tunnel survey manager as well. So I didn't have so much to do with the tunnel itself, but overall there were 21 surveyors at its peak, and a lot of that was because there's a lot of shift work, so we needed at least 2 or 3 surveyors per shift, and there were 3 shifts of 8 hours. But also what's not shown in here in the team is because we had a lot of monitoring, a lot of it for consent purposes, and that was done with digital levels. So we also engaged the services of Unitech, who was right next to the project, and that was great experience for the students to go out there and do some leveling for us and do some data capture and help with their studies. So the equipment we used, as you can see the list there, we had quite a few total stations. At that point, the new Faro S120, I think it was called, came into production, and I was pretty keen to get my hands on one. Trimble also got that same thing and called it a TX5. So we were able to use that a fair bit. We had a bit of machine control on the project, a few diggers hooked up to Trimble machine control systems, and yeah, a lot of GPS units as well, a lot of rovers, as well as all the digital levels to do the monitoring. And we had a bit of a quiver of digital levels. We had a Trimble one for the rainy days. It had the higher IP rating, and then we had a Sakia, which we spent a bit of money on, but was literally magic. It could read the barcodes on the staves from literally around corners, and we couldn't quite figure out how it worked. We did so many tests on it, but yeah, it could read the bar in very strained conditions. Plus, it had the autofocus, so it just sped up everything out of sight. Software we had typical 12D, Civil 3D, Trimble Business Centre, and T4D, which I'll go into shortly. But also we were using the Trimble iBase at the time as well, so we didn't need a base station of our own. So surveying the surface, it's involves setting up a control network, set out, as-built, topo surveys, and monitoring. So I'm just going to go over each of those. So control. On that project, it was a bit of a mix. We got people in to do the control for us at the start. I learnt a lot about that, and from this project onwards, we made sure we did all our own control, because we had various people from various companies coming in and doing it in various different ways, and we lost all control of the control. So we could put our own control off what they'd provided, but these other people that would come in, we'd sometimes disagree with their methods, and yeah, doing your own survey control is quite important to your satisfaction on the job. So fast forwarding to City Rail Link, we did it all ourselves, and we kind of over-engineered it, but we were so comfortable and confident on that project, and still are with Sam, who's taken over there. But yes, it's we use Trimble Business Centre mostly when we were doing our own control on this project. So set out. So as mentioned, we had a couple of machine controlled excavators on site. So that's part of set out, right? Even because we have to create these models which can be used by either the total station or the machine control equipment, or the GPS equipment, or maybe even to be used by engineers sitting behind a desk. So it all, to me, all forms part of set out as part of the data management as well. So in this case, for machine control, we're having to create these 3D models for the excavators to cut to. But this is the fun stuff, really. This is what really gets me hooked on engineering surveying, is the set out with total station of these complex structures. So as you can see, top right there is the model for the interchange ramps up there at Point Chev, and yeah, down at the bottom left there, there's the model, or in the middle there's the model, and at the bottom left there's there's a rendered model of the Hendon footbridge, we called it. I think it has another name now, but that was very architecturally designed, right? So yeah, lots of angles and curves and things which are not square and easy. So on this particular bridge, this was where we really had to think about our scale factor, because that suspension part there, it's a combination of suspension and column. So that suspension part was prefabricated off-site and was 130 meters long from memory. So we had to make sure that those ends were going to fit perfectly to the suspension truss that was going to come along. So we had to make sure we removed the scale factor on that particular part of the project. Otherwise, we left the whole project in Mount Eden 2000. And I don't think I've got a slide on it, so I'll tell you now about that scale factor. It was there's always a lot of debate whether you take the scale factor out or not. But because at the end of the day, it all has to tie in with the survey system and the cadastral system, it's best to leave it in. So because of that, we had a lot of people from around the world coming to do this project, and they would come in, and what's expected with the tunnel is a bit of what they call ring creep. So as your concrete segments are placed, each one being 2 meters, they get them pretty precise, but there's always a fraction of a mil per ring, so that by the end of it, your tunnel is a bit longer than what you thought it should be. But because we didn't take the scale factor out, the rings actually came out where they thought they would if each segment was exactly 2 meters wide. And I always remember those meetings where the engineers were amazed at how there was no ring creep. And I was trying to explain to them, yes, there was, but we've got a scale factor on this, so it's been counteracted, so that's great. And you could see it just went over all their heads, even though they're quite smart engineers. They still stuck with their story that it was so great how they managed to eliminate the ring creep. But otherwise, yeah, you can see the bottom right there. That's a total station setup for doing some of the set out for some of these on ramps and off ramps. Oh. Okay. So this is the breakthrough of the TBN. So this is a little private one that only a few of us got to see. Politicians got to see the final one, and everyone got to see that. This is the first one. We're all confident but nervous. First big thing like this in New Zealand, and the sound is impressive. It's like a whale. And then you realise it's more like fingernails on a chalkboard. It's metal on concrete on the street. And 14.5 meters concrete coming down. It was quite a moment. Seen a few other videos of breakthroughs, and I have to say that this one seems the more spectacular. They all come through in different ways depending on what kind of concrete they put in. But for our one, there was no reinforcing at all, so it all just came together. So yes, a very, very impressive breakthrough. Made a lot of noise. It's very exciting. Definitely a highlight moment of my whole career. And yeah, I've got that under the heading of set out because, as you can imagine, if that's not coming out in the right place, then yeah, there's no going back on that. You've got to make sure your set out of that tunnel boring machine is on the money the whole way. And even though we've got our methods of bracing the traverse as we go up, it's still effectively a hanging traverse. So yeah, very, very good work of the survey team there to get that through within 10 mils. They said. Other forms set out. So we set out the skate park. They did a new skate park. We scanned we also scanned a BMX track and set that out. So scanned a BMX track from somewhere else in the city and basically copied and pasted it. So vent buildings. There's a lot of buildings set out. It's a multi-story building. If you look in the bottom right, which is a model of what there is today. You'll see that as you're coming in from the south. So there's many stories in that vent building, a few offices in there. We had to divert creeks. We had to set those out. There had to be rocks which are placed in specific locations along there. We did sports fields and, of course, the countless utilities. And then there's the topographical. We inherited a lot, well, pretty much all the topographical information. So it was one of our challenges, especially as the design team are using it. All the work of other surveyors suddenly becomes our responsibility, and anything that's not right gets put on us to fix. Or to explain why it's not like how it is now. So yeah, these topo surveys again were done by many different firms. So we had to paste it all together and take ownership there and put it into all one single model there in Civil 3D. But we also used our scanner to go and fill in some gaps, get the underside of the trusses as they went up, the Super T beams, but also great tool for getting the busy roads. So I was quite proud of our little system we made for holding a checkerboard, a checker target, so that we could put the scanner in the place of the checker target on the same tripod and tri-brack, and it'd be centered, and you can get the total station to measure to that. So all these points were nicely coordinated. And then we had to do a lot of as building as things were completed, as structures were completed. It it's always part of the handover to show that the whole project is built where it was meant to be built. But always on these projects, it's very critical for the underground services. So we had a bit of a system here of whenever a service was completed, that an engineer would log a job, and then that job would link to that data. So it was available for anyone to see at any time. In City Rail Link, I expanded on this a lot further. And we had this linked to the data as well. So the as-built data was basically live, and all the surveyors knew the format and the accuracy and everything that was required of their pickup on site, so that it could be quickly transferred into the system. So when I say live, there's always processing, but the guarantee was that there was no data more than a week old, which was important for all the decision makers there, especially in a busy street like Aotea. But yeah, that was City Rail Link, and Waterview, there was a lot less services, so not so much problem there. Monitoring was a big part of this project. For consent monitoring, 144 marks per week. Those were weekly marks, and this changed regularly as well, but this was a snapshot in time. And we had another bunch of marks that were 245 per month, using the digital level and processed in Trimble Business Centre. So if you can see this image here, you can see on the left here, this is our little database of monitoring points. You can see the motorway on the left here, and you can see the whole length of the nearly 5 k's of project connecting up to the end of the motorway on the right. And you can see every one of these green crosses is a monitoring point. So overall, it was over 2,000 monitoring points. And as you can see, they went quite a far way out past the extent of the project. So yeah, a lot of work for our monitoring teams there. That was all done with digital level, like I've said. Monitoring for construction, so a bit different to monitoring for consent. Monitoring for construction is where we really think there might be something going to happen. The structural engineers want to know that their structures are holding what they predict it will hold. So one of the key components was when we crossed underneath Kiwi Rail line at the back of Pack and Save. So this is where we first started investigating our real-time monitoring as it first went under here. Actually, no, we had the real-time monitoring set up as we first set off, but this was a good use of it as well. So we had live information of any movement on the tracks as we installed prisms along the tracks, and had a total station there set up 24/7 with a guard and just continuously measuring. We also use the scanner to monitor as these walls were excavated out. So these walls on the side are called diaphragm walls. So they're constructed in the ground deep using the grabber. You may have seen them around City Rail Link or around this project at the time. Very impressive piece of kit on the end of a crane, and that excavates down. But to create the walls, but as the ground is excavated between them, we need to make sure the walls are not falling in, right? The structural engineers had allowed for 80 millimeters of movement of those walls, and we found no practical way they wanted to monitor as soon as the wall was exposed, but as you can imagine, it's very dirty. There's an excavator there working against those walls, so any prisms you put in there, or even any sticky targets or anything, is either going to get covered in mud or knocked off by the excavator. So the scanner was a good option here, and it was agreed all they needed to see was convergence. So absolute position and height change was not so important. They just wanted to know if the wall was coming in or not. So the scanner was a good tool in this case. And then you've got the real-time monitoring area. So this area is on Great North Road. Great North Road is considered the busiest local road in the country. I think they said it was 20,000 cars per day. So we had to make sure that that road was not going to move as the tunnel boring machine went underneath it. So again, using the real-time monitoring setup, using Trimble and T4D as part of Trimble to give live information on any ground movement. So yeah, it was quite stressful at the start as it really came to the crunch, and throughout as the TBM moved through this zone. But it was really effective, and we used, if you can see here, we came up with a few little ideas on how to do this effectively. So you see these two left-hand pictures, little contraptions we made up to hold a prism on top of a pin in the ground. So it's set up so that the prism can move up and down. We weren't too fussed about horizontal movement. We really wanted to know the vertical movement. So this allowed the prism to move up and down with the pin, and the pins were concreted in reasonably deep. We also had these cat's eye prisms that we could stick on the roads, and the bottom right images of the head wall as it broke through. So we had real-time monitoring on the head wall as well, which would have been our first indication if our set out of the TBM had not quite worked, as it would have been pushing through in an area where it wasn't supposed to push through. Yeah, but it caused a whole lot of movement, which, yeah, we wanted to make sure wasn't happening. So yeah, still more on the T4D control. So as you can see there, the total station setup being powered by a laptop. Top image there is from the control panel of T4D. And in this bottom left image, you've got to try and do Where's Wally and spot the grey total station in a world of concrete. But it's there on a little platform we'd made for it, cantilevered out to the side so that it can measure the whole head wall, as much of the head wall as we could see from that point. And this is what the engineers would see from our results, from our data that we were collecting. So as you can see, each colour on the graph is a survey point or a prism, and you can see over time, now being the far right, the past being the far left. So you can see in the middle there, it's some points have started to drop away, and that's where the TBM starts going underneath. And in those moments, when you've worked so hard on making the system work, but when you see that, if anyone else going, oh, what a boring graph, but for us working on this, you just go, oh wow, it's working. And you can actually see where the TBM is based on the settlement of marks, and our gear is picking it up. Awesome. So again, another little highlight. Anyway, I have kind of blasted through that. That's my career highlight, and it's my highlight because I was involved in pretty much all parts of the project, and I was able to bring a lot of innovation, and it's where I first became survey manager as well, and all the drama surrounding that as well. So yeah, it was a great time in my career. 8 years ago seems like last year, but so many learnings from it, and yeah, such a great project. So I'll leave it open to you guys to ask any questions. Otherwise, I'll hand back to Jane.
Thank you, Mike. That's amazing. Really, really exciting. I've really enjoyed that, and I hope that everyone listening in, and if you are listening in on the library now, that you really enjoyed hearing it from Mike. Mike, there aren't any formal questions that have come through yet, but I'd just like to say to those listening in right now, please feel free to type some questions in. We've got a little bit of time. I've got a few questions, Mike. I've taken quite a few notes here, and I'm sure everyone would be inspired to hear. I took notes when you said, this is what gets me hooked on engineering surveying. Set out with total station of complex structures, and you talked about lots of angles and curves, and obviously setting out bridges, roads, walls, all those things. I'm just wondering, first of all, if you want to expand on that. Obviously, this is 8 years ago. We're assuming you're still hooked, and this is not an isolated project. And also, following on from that, I'm really interested, as I'm sure others will be, to know what kind of an impact Alice and the lessons that you learned from the Waterview Tunnel project have had on today, and how they continue to impact. Did they set any precedents that previously hadn't been set, and how is that influencing the projects that are around at the moment? I know City Rail has continued, and we've had who is she, Dame Fina,
Yeah.
and others. So just putting.
Okay, yeah, so yeah, expanding, first question, expanding on what got me hooked. Well, it was long before that, but yeah, the set out of the complex structures is like, yeah, you go through survey school and there's a lot of talking about pegs and boundaries and that, and you go, yeah, that's quite cool. Yeah, you're creating value from land by putting in pegs, and you're changing the land and all that, and that's quite cool. But when it comes to these kinds of projects, and instead of a wooden peg, you're putting in a little concrete nail and drilled into a bit of blinding concrete, and then you go away and come back a few days later to do the next stage, and your nail has turned into a big concrete abutment. And then you go, oh, that's pretty cool. And then you go into the next part where you mark out for the Super T beams, and you line all that up, and you put some marks down, and then you go away and come back the next time, and all these Super T beams have gone in right on top of your marks, and then you go along and you mark out these walls, and you make a lot of effort into getting the accuracy and getting enough nails on the ground, and then you have a good team working with you that then puts in the wall panels, and then you come along afterwards and you see it perfect, along the line, perfect curves or perfectly straight lines, and you go, wow, that's cool. And then now I drive past it every day, and every day you take a look and go, yep, still straight, that's good. thanks to our team. So yeah, that's what got me hooked on it. So yeah. Any onto your second question, lessons that you learned, the precedents that were set from Alice. Like one of the lessons that just that first springs to mind as a country as a whole in these projects is that when the Waterview Tunnel finished, there was no CRL then to go on to. So I had to occupy my time on, not saying it was a lesser project going up to Puhoi, but in general, a lot of the talent we had left to go and follow where the other tunnelling projects were around the world. And so when the City Rail Link kicks off again, we have to bring it all back in again. So yeah, that's something I would have liked to think we would have learnt from that, but it doesn't look like it. So yeah, continuity of projects would save taxpayer a bit of money, I would have thought. But that's a holistic view. From a surveying point of view, like there's so many day-to-day lessons that we just learnt. That's where I became survey manager, and geez, I learned so much about HR at that point. But yeah, from a survey point of view, I kind of mentioned about the survey control networks. That was one of my biggest learnings for the next projects, was to make sure we did that ourselves and understood what was involved there, so we could do it ourselves. But apart from that, a lot of it is just learning how to work as a team, right? And you're working with site engineers most of the time, and it's as much people skills as it is technical skills. So yeah, learning how to be empathetic to those you work with to get the job done. So
it's amazing. Thank you. Something I didn't mention at the beginning for everyone listening in is that Mike has been absolutely key in spearheading our engineering surveying certification project, and he is actually the first certified professional engineering surveyor in New Zealand off the back of our certification pilot that we ran a couple of months ago. I'm involved in that project, and something that I picked up on what you said, Mike, I just want to ask, I was fascinated when you were talking about the fact that you did not remove the scale factor, and that managed to counteract the ring creep. That just sort of made me remember some of the things that we talk about when we take would-be certified engineering surveyors through their interactive assessment. Is that something that is isolated to this project, or was it something that you hadn't come across before and it was an innovation, or a fresh thinking? Have you got anything to comment on that? Because I picked up on that and thought, oh, okay, that's something that is out of the norm. So.
Yeah, like I say, yeah, definitely close to being an honorary surveyor there, Jane. Good spotting. Yeah, the scale factor is always a thing on big projects. If you're a surveyor and that's not your first question, then yeah, you need to take a closer look, because scale factor is always a thing to think about. But the ring creep thing was a kind of a side effect. It wasn't something planned. It's not something that we said at the start, oh, there's going to appear to be no ring creep because there's a scale factor. No, it was just something at the end. Is just like, there is ring creep, but it's not measured. And then another big learning from that was to avoid trying to explain to anyone else what a scale factor is, because especially on big projects like this, like trying to explain to these designers and CAD operators that the meter that they draw on their plan is not actually going to be a meter on the ground. They don't want to hear that. It makes them very worried. So yes, scale factor is definitely a big issue, and it's definitely the first consideration as you start any project.
Thank you. And another question I have is your choice to use the TX5 scanner to monitor as the walls were excavated out, and obviously the engineers wanting to see regarding convergence, and obviously that you pointed out clearly what the choice to use the scanner. I know that is something that in our certification pilot we have required and asked people to outline the decisions and the reasons for the decisions on what they used. Was that something that was new? That choice to use that TX5 scanner, was it an experience? Had you used it on that scale of a project before? yeah, I'm just wondering how that might have impacted not only the choice on that project, because obviously it seemed to make sense from your presentation, but whether that has influenced your decision to use or not to use a scanner in a similar situation since, in the 8 years since.
Yeah, good question. I like your questions. That was completely kind of on the fly, and part of my supporting argument to get one of those scanners. I really wanted a scanner, but it was a legitimate reason to use the scanner here. Like I said, it was just forgetting the wall as soon as it was exposed, so picking it up. Would I use it again? Yeah, we learnt a lot on that, and yeah, you have to have some better systems than what we had to get it working properly and efficiently. Yeah, I would avoid using it in the future, but definitely learnt a lot by using it, and yeah, we were able to get the results we needed, just not as so the sacrifice there was it was efficient on site, which was great. We weren't in anyone's way, but it cost a lot of time in the office. So it used a lot of office resource to make sure we got the correct results. So yeah.
Interesting.
I see there's a question coming through.
Yes, so there's a question that's come through. How far did the team go with QA in terms of independent checks on others' work for as-built and setting out? And also comment that this is a great presentation and everyone's enjoying it, so that's good.
QA, yeah, independent checks. So it depended what. I mean, there's so many facets to that project. In terms of as-built, QAing as-built, there wasn't much, but we had set it all out anyway. So the as-built was kind of like a QA on the set out, so to speak, because there was another person coming along and as-building it usually 6 months later, and the team had changed and moved around, so we'd pick things up then as it was as-built. But set out needed QA. That complex Hendon footbridge needed a lot of teamwork to get the set out points for that. So a lot of QA on the set out for that, and there was QA on the set out of the tunnel boring machine halfway through. We got an independent survey company from Australia who brought in their gyro. So that's another form of survey equipment which just checks that we're heading in the right direction more than anything else. And yeah, at the end of the day, they were making a few errors as well, and we were quite confident in what we had, and they were telling us we were wrong, and we were telling them, no, we're not wrong. You need to check again. And so they checked again, and they said, you're right, you're not wrong. so yes, we did have some QA. Yeah, we QA'd our control, which was us QAing others' control, and that's why the project's going ahead, we prefer to do the control ourselves and then get someone else to QA it. But yeah, plenty of QAing going on all around, and yeah, there's always a big quality assurance team there, but they keep an eye on us as surveyors, and they just make sure we've got good systems in place. But they're more for everything else in terms of construction. Mostly around structural integrity, right? So yeah.
Brilliant, thank you. I've got a couple more questions. Mike, you commented on your as-built data that it was live, as in no more than a week old. Your comment on that, was that because that's not always the case? I know that I've picked up during our pilot certification project the question around the data, and obviously in this case it was to ensure smooth processes and everything. Is that something that you personally aim for? Live as in no more than a week old, or was that particular to this project because of the scale of it, or the complexity, or the time frame? Have you got any comments around that from your experience?
So that 1 week old thing, that was for City Rail Link. So just kind of fast forwarding into the future. And in Waterview, there was no requirement to be live, but yes, for City Rail Link, it's very much needed that be live, so that design decisions can be made. So myself as the survey manager, I took full responsibility of that and set up a very robust process that I overlooked, and made sure the team was sticking to it, and I gave that number one priority on the project. That was always my first attention. Other things like control is important, but there's time to do it, right? Whereas the as-built, you had to stay on top of it, and especially with the complexity and the amount of as-built and the risk. If you're cutting fiber optic cable in the middle of CBD, then yeah, you're costing a lot of money. So yeah, that was very important. So yeah, we set up that process there. It was reasonably unique. I'd investigated many ways of doing it using GIS tools and things like that, but at the end of the day, it was just simple AutoCAD, and we had a BIM collaboration platform. So this live document, it was just a DWG file, and that document was live. No one else touched it. No one else had permission to it except myself. So I was the only one putting data in, and yeah, it was my sole responsibility. So yeah, I handed that off as I left. So yeah, there's one person who keeps control of that. So.
Wow, that's amazing. And just finally, for those listening in, I'm not sure if they've got the same question in my mind. I didn't write down the brand name, so forgive me if I haven't remembered it correctly, but you did mention under the Waterview Tunnel project your considerable investment in, you had the Trimble equipment, but you also invested in, was it Seneca? Is that right?
Yeah, the digital level, the Sakia,
sorry, yeah, Sakia, and how fantastic that was, and the fact that it could read barcodes around corners and that kind of thing. I just wondered whether you had any comments on that, and if that has influenced how you take advantage of the I guess the strengths of different pieces of equipment since or similar.
Oh yeah, definitely. And that was the whole another one of the fun parts. As I was a site surveyor before becoming survey manager, the fun was setting out these structures. But as you're a survey manager, the big fun then was buying new toys, right? Big $1.4 billion project. You get a little bit of slice of that for yourself to spend on toys. And yes, it is a kid in the candy shop kind of scenario. So yes, you do a lot of research. You have a bit of fun with the big suppliers, trying to see what the latest and greatest is. That Sakia thing, I haven't used it since, just because it is so niche, so good at that specific task. I haven't had to do something on that scale since, and I think the consenting has become a bit more rational since then. There's so many points to be monitored. Well, and also since then at CRL we didn't do any of the monitoring anyway. We subcontracted that out to another big player. A big player in the industry who does all the real-time monitoring, so I didn't have to worry about any of the monitoring. And they've got systems of their own, and they have big, expensive systems so they're called 6 Sense. But yeah, I'm kind of dancing around your question there. I think I've answered it.
You have, indeed. Thank you so much, Mike. Just really, really appreciate what you've shared today. Definitely you're passionate about what you do in engineering surveying, and it's just fantastic to hear about some of your career highlights. So thank you everyone for listening in today, and please share the link, and I hope that you access this in the library, and this is going to go down for some time to come. So thank you very much, everyone. Bye.
Thank you, Jane. Thank you, everyone.